Yeah, you're good to go. Yeah.
Okay, perfect. Thank you. Hello, everyone. Welcome to my session about the No More Identity Thefts, where I'm going to talk about identity security. I hope you had a wonderful event so far. Remember to stick to the end. You have a chance to win exciting prizes. And also a big thank you to both the sponsors, the organizers, the volunteers, my fellow speakers, and last but not least, all you people in the audience. Thank you so much for being here. So I'm going to start by introducing myself. My name is Per Torben Sørensen. I'm 46 years old. I live on the south coast of Norway. I have worked in IT for 26 years now. My focus area is M365 and identity security. And I am a person who really enjoys warm weather, and I don't really thrive in cold weather. So in that sense, Norway is the wrong country for me. Me and my few of my colleagues, we write a blog, agderinda.cloud, and I am easiest to reach during LinkedIn, and I will give you the LinkedIn profile at the end of the slide deck. So moving on, I've never been to India, so I thought it would be very fun to compare Norway and India slightly. And I found out some interesting facts about both countries. Among them that New Delhi has almost about 5 times the population as the entire Norway. So it's quite a big difference in size of populations. According to Google, you are pretty close to the equator, while we in Norway, we are pretty close to the North Pole. We stretch up to 71 degrees north, and as you probably know, 90 degrees north is the North Pole itself. In case you don't know where Norway is on the globe, I don't blame you, because we're tucked away pretty far up in a corner up in Europe. But you can see India on the bottom right side there of the map, and you have mainland Norway with Svalbard, our archipelago, up by the North Pole. Should you ever come to Norway, and during the summer, you can find vistas like these ones. And if you are not like me, but actually enjoy snow and skiing, then we also have many opportunities for that, and not to mention the Aurora Borealis. Anyway, that was the introduction. I'm gonna have a session and I'm gonna talk about something that is very near and dear to my heart. What the fuss is about? It is about MFA, still. And I assume all of you in the audience know about MFA. You talked about MFA before, you heard about MFA before, but please stick around. I'm gonna share some of my personal experience with this. So in case someone in the audience doesn't know, MFA is multi-factor authentication with the sole purpose of verify who you are when you sign into your services like Teams or Outlook or SharePoint or whatever the case may be. The factors are used are something you know, something you have, or something you are. Something you know is like a password or a PIN code. Something you have can be like your mobile phone or a physical security key. Something you are is typically a fingerprint or a facial scan. And multi-factor authentication just means that you use at least 2 of these 3 factors when you sign in to verify your identity. So the problem, it's the MFA nagging. And these are 2 pictures from Microsoft, where they showed statistics like 99.9% of compromised accounts did not have MFA, and basic security hygiene still protects against 98% of all attacks. That's well and good. And I work as a consultant. I meet new customers, and I want to talk about MFA, and this is what I get, usually. Not surprisingly, because the statistics from Microsoft is, without any offense to Microsoft, a bit nagging and a bit dull. But as I always ask, is this the first time you are told that MFA is important for your security? No, it is not. But still, when I come to a new customer and take a look at the MFA coverage, it is always bad. And which is quite scary because MFA is the foundation of your security in the cloud. And if you don't verify your identity, it will leapfrog over all your security measures within access management, your purview with DLP and sensitivity labels, everything that is built upon the foundation that you are the person who actually signs in. and MFA is the way you validate that. And it surprises me to learn that a lot of people doesn't realize that an account doesn't register MFA until a user actually signs in. And when they sign in, they also get a requirement for MFA. Because if not both those things are present, MFA is, the user is not asked to register the MFA method. So what I did, I took some real life example. I took 5 random customers as I worked on the last 2 years, where the smallest one had about 700 accounts in their tenant and the largest had about 20,000 accounts. And then I checked how is the MFA coverage. And this is how I got. So the red is obviously the amount of accounts in the tenant without MFA, and it is 61, 68, 37, 46, and 92% of the accounts did not have MFA. And this graphics here shows why we cannot stop talking about MFA. And I know we're talking about a lot of other more sexy and more interesting stuff like MCP servers, and we have AI agents, and we have Purview and DLPs, etc. But again, the foundation is MFA, and we need to get this in place before we can build better solutions. And I always get some of those poor excuses like we don't bore scoping, we don't have any critical data. And a customer actually said to me, sincerely, that no, MFA, that's only for admin accounts, not for user accounts. They didn't believe that was a thing for user accounts. And the one I hear the most is that, yeah, we have MFA, but we don't want people to be prompted for MFA while they work from their office. And that is a really bad thing because, like I said in previous slide, if a user doesn't log in and gets an MFA requirement, the MFA is never configured. So in that case scenario, if you exclude MFA from your office building, people who only works from the office building will never set up the MFA and their account will remain vulnerable. Some of the words I get when I speak to other IT managers and I start asking them about MFA and conditional access, and I get these words like, I think so, I guess so, it's supposed to be, it should be a coverage. Yeah, I believe everyone uses MFA. No, these words should not be used. You need to know and you need to verify. Don't believe. And that's actually a bit shame because it is so very easy to check your MFA adoption because you have built-in reports in Entra ID like the one on the left side, where you can see that in this scenario here, 5% of the users isn't capable of doing MFA. And if you want to be more thorough, you can do like I do, good old PowerShell scripts, get all the users, get all the MFA information and put it into either on the screen or on a CSV file or Excel sheet or whatever you want. Because the problem with this is account hijacking. And accounts are particularly vulnerable for hijacking before MFA is set up. So my first advice is don't create or sync stale accounts into the cloud. So if you have typically a migration project of 6 months, then you start to synchronize all those users over because you want to migrate their data. But if you do that and you know that the user isn't going to sign in for in another 6 months, then make sure you secure or block them from signing in before they're actually going to be used. If not, they will be idle in the cloud and will be vulnerable for hijacking. So if you need to bulk protect accounts like this, there are 3 MFA methods that can be deployed with scripts. You can use SMS codes, but I really recommend that you don't use them. You can set up temporary access paths, and you can actually configure using PowerShell 5 keys on behalf of another user. I have a blog post on that on my blog. So what if you don't have MFA? Well, the good thing is that somebody has already tried that before you. What happens if we don't have MFA on all our accounts? Microsoft tried that, and they got hacked. This was in January 2024, if I remember correctly. It was actually a test account, which did not have MFA configured. Now, the test account did not have any particular good access, but they had access to an enterprise app, and that enterprise app had access to Exchange. So they just got the password through a password spray attack, got access to the app, and used that to exfiltrate emails on a director level at Microsoft. So we need MFA on all accounts, even test and demo accounts, they all need MFA. And as you probably know, in November 2022, we got ChatGPT. And of course, it's not only the good guys who use AI, the bad guys also use. So they started to create what they call bad GPTs. And what's happened last year was that in Hong Kong, there was an AI heist using deepfakes in a video conference call. For an employee was convinced that he was participating in a video conference with other employees, including the financial director, and they were able to convince that poor user to transfer millions of dollars to their bank accounts. So yes, we need to verify who is logging on, which is precisely what MFA is for. Also, we have Snowflake. Snowflake is a data warehouse, but they don't offer any tools to enforce MFA on there, at least not in 2024 when this happened. And a lot of the customers were breached because of this, including Ticketmaster. And the one from Ticketmaster is actually bad because it is 1.3 terabyte of data for 560 million customers. And that is about 1/3 of India's population, and that doesn't pack the same punch when, like I say, that is 100 times the population of Norway, but it is the same number. But 560 million customers had leaked their full name, address, phone numbers, email address, order history, partial payment data, which included the name, the last 4 digits of the credit card number, and the card expiration dates. That's really, really bad. So yes, like I wrote there on LinkedIn, MFA on all accounts at all times, because this is potentially the consequences if you don't. So I hope we learned yet, we need MFA everywhere. So we are now halfway in 2025, and when we are working on the cloud, passwords alone, they offer practically no protection at all. So if we want to have security, we need passwords to be combined with MFA. But then how do we make sure that all our accounts are protected with MFA at all times? Because that's what we want. We want to close all those loopholes. And this goes over to the second part of the agenda, the conditional access hardening. So conditional access policies, or CAP, as I like to shorten it, it is your primary tool for identity security in Entra ID. It's not the only tool, but it is the primary tool. Briefly speaking, it is something that evaluates every single sign-in based on a given rule set. And from there, it goes on to either allow access or block access or put extra requirements like MFA or compliant device, etc. It is extremely flexible, and it is continuously improved and expanded. So now you have tie-ins to Purview, you have tie-ins to Intune, etc. And you can use all these signals to create a rule set to say what should happen if a user signs in under a specific set of circumstances. It requires Entra ID P1 license, and for a P2 license, you also get additional features, like, for example, you are able to set up conditional access policies based on user risk and sign-in risk, which is really useful. It is a very powerful tool, but it does have a few caveats, so that's why I want to go through some do's and don'ts. The first thing you do when you're working with conditional access is establish a break glass account. If you today do not have a break glass account for your tenant, this is your priority number 1 after the sessions today. If you're not sure if you have a break glass account, this is your number 1 priority after the sessions today, because you need to have these before you start messing about in conditional access, or you have an intruder who does the changes in the conditional access policies for you. You use conditional access policy to enforce MFA on all accounts, and I just showed you why you should do that. And make sure that you explore all capabilities in conditional access, like, for example, how to use Intune. You can use identity protection, you can use Purview to set up additional rules. Privileged accounts like global admin, exchange admin, etc., they need additional security. And everyone who has troubleshooted sign-ins which are blocked because of conditional access policies know that using a naming standard is a really good idea, because it can be really tricky to see which policy is actually causing the error. There are some sign-in methods that are less secure. For example, Exchange ActiveSync, SMTP, POP3, etc. Make sure you block those less secure methods. Don't exclude MFA for Office networks. I see that so many times. Please don't do it. Also, when you work with conditional access policies, don't just set the policies, see that they work, and then forget about it. Revisit them. I said 2 slides ago, they keep getting changed, they get improved, they get new capabilities. Make sure you revisit your setup and add those new features in to get your security posture as high as you can. It is possible, but difficult to lock yourself out of your own tenant. I have tried it, so I know it is completely possible. That's why you need those break glass accounts, because you can be unlucky, and that break glass account is the way for you to get back in without contacting Microsoft support. Of course, test all changes before implementation, and I say of course, but I need to write it up because I also helped customer where exactly that happened. They just implemented new conditional access policy without testing. And conditional access policy is something I like to compare to the traditional firewall in a traditional Office network. So you want to have it monitored. So if someone changes your conditional access policies, that's an alert. That is a red alert. Same for rule backup. Make sure you have a backup of your conditional access policies so you are able to get back to your last known good configuration. And once again, don't forget to verify your coverage. And I will show you that in just a few minutes. But the big issue with conditional access policies, it has, in my opinion, a major design flaw, and that's its default behavior. Because by default, you are allowed to sign in without any form of MFA. So this means, unless anything else is specified, you can sign in from everywhere, from any device, you can access any app, all of them without multi-factor authentication. So in order to solve this, we need to attack the default behavior itself and change it so that unless anything else is specified, you are blocked from signing in. Same principle again as the traditional firewall in your Office network. You block all traffic and then you open up which traffic you want to let through. Apply the same principle here. Block all users and then explicitly allow those users you want to sign in to sign in. So to do that, I've made a framework for conditional access policy based on Microsoft's own framework, which is available on Microsoft Learn. I have adjusted to, well, I'm not sure if that applies for India, but at least in Scandinavia, we have absolutely no companies that is nowhere near what's the American enterprise segment. But again, it is a framework, not a final solution. So it's something that you should always adapt and expand to your environment and to your needs. But the goals are a better naming standard, want to block sign-in by defaults, systematically assign a conditional access policy to each persona. I'll explain in just a second. You get a full control on which accounts which can sign into your tenant, and all of this in 5 easy steps. So step 1, establish your personas. So persona are simply the different kind of user accounts you have in your tenant. So an example could be like this. You see we have the global, which should apply to all accounts in the tenant. You have privileged accounts, you have users accounts, you may have some service accounts, you have guest accounts, and this list will be different from every environment, and that's perfectly fine. For example, a university may end up with a list looking like this, where you have faculty, you have students, you have research accounts, etc., etc. But this is a pen and paper exercise done by someone who knows the environment properly. Step 2, you create a group corresponding to that list from step 1, and then you establish a naming standard. My naming standard is like this. I write CA, the persona number from the previous slide, sequence number, which just goes from 0, 1, 2, 3, 4, etc. I write the persona, the target, and the requirement. Something like this. So you see the top one there, 0001, that is a global. The target is device code and a block. So that blocks device code sign-ins. 0100, that's for admins. That's the default protection for the admin. And I'm saying that all admins should require multi-factor authentication, etc. Step 3, this is where things get really spicy. And this is where you can, if you're unlucky, lock yourself out of your own tenant. So we block a default, we create a default rule, which is the default block. And it looks a bit like this. You assign it to all users and all cloud apps, block access, and then you add to the exclude list the accounts you want to sign in. So you see in the example here, you have guest accounts are allowed. You have 3 groups here for admins, users, and service accounts, which corresponds to the list in step 1. And of course, the break glass accounts. So they are excluded. The beauty of this design is that if an account is not in this list, they cannot sign into the tenant, period. So you get full control which accounts can actually sign in. And this allows you to make sure that all of them are hit with a conditional access policy, which again can then enforce MFA, which again leads to a much better MFA coverage of your accounts. So step 4, we start with that list and then we add a default configuration per persona. So for each of these, we add a default configuration. So it can look something like this. This is an example. So you see we have admins, default require MFA. That's the apply to the group there. Users, default require MFA. That's the one. Let's say you have some service account, the old-fashioned type. Okay, then let's say we always require them to sign in from Office network. We block other networks. It's not a good way to protect them, but it's better than nothing. And of course, guest accounts, yes, they should also use MFA. And when I say default, that is what is the minimum protection for that persona. And then you just add on several rules to add or customize their protection. I will show that in a couple of minutes. And the goal of this setup is to prevent that you have any sign-ins without any conditional access policy applies. So the goal is 100% of sign-ins are hitting at least one conditional access policy, which then provides the protection for that sign-in. So step 5 is really important because looking at this setup here, what happens if you delete that group, CO01 admins? I have tried it. I recommend that you don't try it because if you delete that group, then yes, your admin's account are blocked from signing into your tenant, of course, except for the breakless account. So we need to protect these groups very carefully because they will be the key to the kingdom to get access to your tenant. So step 5 is to use restricted admin units to protect those groups. So in case you don't know, an administrative unit in Entra ID is a way to delegate admin rights to an own part of Entra ID. And it can be users, groups, or devices, and you can delegate to a specific set of users to have, like you can see here, user admin, helpdesk admin, and they will have admin rights in this AU. They will have no admin rights on the rest of it, only for this part. And an ordinary global admin account will, of course, be admin of all of it. But the secret sauce here is that you use restricted AU, which works on almost exactly the same, but it blocks other privileged account from doing changes. So this means that in this restricted admin unit, which I've called conditional access, I have those 3 groups in the conditional access policy. Since this is a restricted AU, no admins can go in and do changes to these groups. Only the accounts specified can go in, and they will get a custom role to only change the group membership. So they cannot do anything with the groups except changing who is a member of those groups. That's it. Of course, if you are a global admin or you are a privileged role admin, you can change the restricted AU itself and thereby gain access. But you will never accidentally delete it, and an intruder will need to gain either privileged role admin or global admin in order to change this. And if you have an intruder in your system with global admin rights, then you are already gone. Sorry, but then it's too late. So in summary, privileged users, ordinary users, for example, into each of their own group, which is protected by restricted AU, and they are then applied their set of conditional access policies. So, demo. What can go wrong? Something like this. So this is an example of how such a setup can look like. As you can see here, we have these start with CA00. Those are the global settings. They will hit all user accounts. So you see, we have the default block. We block device code. We can record MFA for user risk, sign-in risk.
Just a small reminder, we have 10 minutes left.
Oh, okay. I'll be quick. And so on for admins. As you can see, we have this is the admin unit with groups protection. Here are the two groups, and I have here created a custom role, which allow them to change membership. So this admin account is the only account which are allowed to change the group membership. I'm still signed in with a global admin, so if I find one of the group here, you can see I cannot delete the group. It's grayed out. And if I go to the membership, I cannot add member. And if I mark a member, I cannot remove them from the group. So that's how it's locked up. All right, guess we'll have to move on then. So, proper conditional access design equals always MFA, but we can do even better. Let's talk about passkeys quickly. The problem with password plus MFA is that passwords are always transmitted along the network. They remain the same and they must be managed. So it is a much better way to sign in using, for example, asymmetric keys, which are based on large prime number, because they have a private public key pair, and they do the authentication for you almost. Like I said, public and private key, they are globally unique, where the public key is shared and the private key is always with the owner. So if a data is signed or encrypted with a public key, the only key that can decrypt or verify the signature is the corresponding private key. No other keys in the world can do that. And the same goes for the private key. Then the public key is the only one which can then decrypt or verify the signature. So passkeys. Passkeys are passwordless and phishing-resistant authentication, which is based on asymmetrical key pairs. And they are made from the ground up to be easier than password and more secure than passwords. And of course, Microsoft make their own special flavor of it. So we have generic passkeys and we have Microsoft. So how do you create a passkey? You sign first in with MFA to an account. When you configure a passkey, they are created and stored locally, the public key, and transmitted to the cloud service. And the private key is stored locally, never exposed, and it is an inactive state. So I want to sign in with a passkey. This can be any service, like for example, GitHub. So when I want to sign in, I send an authentication request, including the public key for that service. The cloud service checks the public key, creates a challenge, signs it with the public key, and transmits it back to the client. This goes in just a couple of milliseconds. Then the user needs to sign in locally with PIN code or biometric, and this activates the private key. That makes it available on the computer. It then uses that private key to verify the signature which came from the cloud. It signs it again and returns it to the cloud service, and that response is only valid once. And then the cloud service can verify the signature, and if everything is okay, provide a session token. So I have a pre-recorded demo here. Signing into GitHub. And like I said, first step, you use MFA. On the right-hand side, you see the passkey settings on my local device. So after I signed into GitHub using MFA, I am able to go to the security settings on my account in GitHub and select password and authentication and set up a passkey. So I want to add a passkey. and I want to protect the Windows Hello, and I would like to use my webcam for authentication. The passkey has been saved, and I just need to give it a display name. And once that is done, you can see the passkey is listed there, and I can now sign out. And if I now check the passkey settings on my device, which you can see on the right-hand side, and I search for GitHub, you can see there I have a passkey stored on my local Windows 11 device, and it is protected by Windows Hello. Not Windows Hello for Business, that's two completely different things. Signing back in, it says here, I have a passkey. Would you like to use it? Yes, please. I would like to stare into my webcam for authentication. Okay, and I'm signed in. That easy. So why are they better? As you can see, no password are transmitted because I never had to enter a password using the passkey. It's cross-platform. It is domain-bound, which makes it phishing site resistant. The authentication is local using the webcam, so it's man-in-the-middle resistant. And that signed response I showed in the animation is only valid once, so you can't do replay attacks either. And as you saw, extremely user-friendly. Of course, Microsoft has their own, what should I say, thing when they do passkeys. It's been in public preview for over a year now. It is still easier and more secure than traditional password plus MFA. So if you have to choose between password and MFA or passkeys, then passkeys are technically far superior from a security standpoint. They are not enabled by default in your tenant. They are not as user-friendly as a generic passkeys, which I just showed you. And for now, Microsoft requires you that the passkey is stored in the Authenticator app, but I know Microsoft is working on allowing you to store the passkeys other places, so that is in development. See, time is running out. So admins, you need to go into the tenant authentication methods on 52 settings, go to configure and enable Microsoft Authenticator under there. Users, open the Authenticator app and sign in. I'll show you in just a second. And you don't confuse this with the phone sign-in MFA method, because that's something completely different. Just be aware of that. And the cool thing about that solution is that the Authenticator app, it configures all the available MFA methods for the user automatically. This is just a picture from Microsoft Learn. You just tap the plus icon and sign in when you add the account. And yes, I don't think you want your admin account signing in on mobile devices to configure a passkey. So for your privileged account, don't use this solution, is my general recommendation. About 3 minutes left, so let's just dive straight into the demo, which is also luckily pre-recorded. So here I go into the user, Peter Parker, and I'm just going to grab his UPN. And on my phone, which you can see on the right side, I will add his account. And instead of scanning a QR code, I choose to sign in. I'm going to leave the UPN there. Now, his account, as you can see, has no MFA methods at all. So we need to add one. So I'm going to add a temporary access pass, which is an onboarding authentication method meant to log someone in so they can set up a FIDO2 key or passkey. So I'm just going to copy that. On the phone, I'm going to sign in, since that's what the Authenticator app. And it says, this is the methods I will now configure on the Authenticator app, because those are the options configured in tenants. The screen on the phone went black there for just a second because it wanted my fingerprint. And then it has set up all those services. So last, I will refresh here, and you can see now that the account has both passkey and Authenticator set up on his account, just by signing into the Authenticator app. So to test this, I will just grab his UPN again, and I will open a guest browser, navigate to myaccount.microsoft.com. I want to sign in, and since this account has a passkey, I'm prompted for it by default. I select the device which has the passkey, which is my mobile phone. The phone I'm prompted to connect with Bluetooth. That's the account I want to sign in. The screen again turns black because of the fingerprint, and then it signs me back in. So according to my time, I have 1 minute left, so I'm gonna spend it on showing you my favorite proverb. So it is, if you want to go fast, go alone. If you want to go far, go together. Thank you everyone for sponsors, attendees, arrangers, everyone. Next session is now coming up, and I am available on LinkedIn, Blue Sky, and there's the link to my blog, Agator in the Cloud. And if we have any questions here, I will be available for a few minutes. Just drop them in the chat or reach out on LinkedIn, and it'll be there.
Thank you so much. Thank you. That was a great session. Loved it.
Thank you.